Today we will be covering measures of central tendency and also variability. So there are going to be three measures of central tendency. Measures of central tendency are values that describe the middle or central characteristics of a data set. These measures provide important information that allows us to calculate the relationship of a given score to the middle scores of a data set. The three measures of central tendency are the mean, the median, and the mode. The mode is the score that occurs the most frequently, and distributions can have more than one mode. If we looked at the numbers right here, we have 1, 2, 4, 5, 5, 5, 6, 6, 7, and 8. So take a second to think about what you believe the mode in this small data set actually is. So in this case, because the number 5 is the most frequent, 5 is the mode. Some disadvantages of the mode is that it's unstable. It may change depending on the methods used for grouping. It's also a terminal statistic, which means it doesn't give any information that can be used for further calculations. The mode also completely disregards extreme scores. It does not reflect how many there are, their values, or how far they are from the center of the group. So if I went back to here, if we had the number 37, 58, and 92, our mode would still be 5. So it's disregarding extreme scores. The median is the next measure of central tendency, and it's the score that's associated with the 50th percentile. So just think the middle number. The median is the middle score. It occurs in the middle of the list of scores, and it divides the data set in half. If we were going to get the height of 5 different people and we had 150, 160, 170, 180, and 180, the median would be the middle number. What you might do if you have a list of numbers is cross out the one at the beginning, cross out the one at the end, and continue to cross out, and that's how you get right to the middle. So again, in this case, the median is the middle number, and in this case, 170 centimeters. When the sample is odd, such as what this was right here, so there's 5 people, so when the sample is odd, the median is the middle score in the range. When the sample is even, the median falls in between the scores. Median is often used on ordinal data and data that's highly skewed. So for example, if we had used our back pain scale on individuals, we might say that most people were a 5. If we were going to take the average of all the scores, that wouldn't necessarily make sense because these are still categories. So again, median might be used on data such as this, although the next measure of central tendency that we'll talk about is also used. So with the median, extreme scores that are radically different from the other scores in the data set do not affect the median. So this might be good and it might be bad. So the median is not affected by extreme scores, again, is an advantage and disadvantage. Because median does not consider the size of the score, but only how many there are, it neglects some important information provided by the data, namely the value of extreme scores. So if we took 5 of my closest friends and then asked what the median income was, it might be a certain number. But then if we put Jeff Bezos in the room, who's the richest man in the world, that might not change the actual median number in the room. Now mean, on the other hand, if we had Jeff Bezos in the room, the mean would certainly change. So the mean is the statistical name for average. Now the mean is the most commonly used measure of central tendency. It's important to know what the median is, and it's important to know what the mode is, but the mean is the most frequently used measure. Its calculations considers the number of scores and also their values. It's the most sensitive measure of central tendency, So changes in scores always affect the mean. So changes in scores might not affect the mode, and they might not affect the median as much, but they're always going to affect the mean. Now, mean sensitivity may be a disadvantage when one or more scores, which are called outliers, so in our case, Jeff Bezos would be the outlier for income in my group of friends, are considerably larger, higher or lower than the other scores. The mean is pulled towards the extreme. So that means that if our mean was X and then Jeff Bezos came into the room, that would pull the mean up considerably. And it would make us all, if we looked at it in aggregate, it would make it look like we all were making a lot of money. I'll give you an example with push-ups. So let's say 10 people in the class do as many push-ups as they can. And these are the numbers that we get. We get 10, 10, 12, 12, 15, 16, 17, 18, 19, and 20. So the sum of these numbers is 149, and now we get the mean by just dividing that by the number of cases, 10. So on average, people in the class did 14.9 push-ups. So now, let's say that we had someone who's great at push-ups. They came into the classroom, and they were able to do 100 push-ups. So now our sum is 249, and our number of cases are 11. And that was, now we have a mean score of 22.6, which is considerably higher than our previous mean right here with just the addition of one person. So that's going to be pulling the mean to the right. Okay, so large scores pull the mean to the right. And it's not necessarily an accurate reflection of our sample when something like that happens. Now, when data are normally distributed, and we will get into what this actually looks like, the three measures of central tendency, mean, median, and mode, all fall near the same exact value. But when data are skewed, these measures are no longer identical. So in the case of our push-ups, we had someone that was really good, and what they did is they created a positive skew because they pulled the mean, which is normally right in the middle of a distribution, to the right. So this would be what a positive skew would look like. Mean gets pulled to the right. In negative skews, means get pulled to the left. So here's another example. If we had everybody in this class and we measured income, it might look like this. It might probably be normally distributed within the class. But then if Jeff Bezos came into the room, his extreme wealth would pull the mean to the right. Other examples would be if I gave this class a very easy test. Most people would score high, but then there may be one or two people that scored very low, which would pull the mean to the left. So here's just a quick recap. Take a second before I cover this. The measures of central tendency are the mean, median, and the mode. If you have these 5 data points, think about what the mean, median, and mode are. I'll give you a second to think about that. Now we calculate the mean by adding the numbers and dividing it by the number of cases. So 1 plus 2 plus 3 plus 3 plus 4 plus 5 divided by 3, or divided by 6 is 3. So our mean is 3. Our median also happens to be 3. So if I crossed out 1, 5, 2, and 4, so in this case we have an even number, so we get what is in between, what's in the middle of 3 and 3. Well, the answer is 3. So in this case, the median is 3. And then because 3 is the most common number, then the mode is also going to be 3. So this would be normally distributed data where the mean, median, and mode are identical. Now let's say that I added in 15 right here. So 1, 2, 3, 3, 4, 5, and 15. That wouldn't change the median at all. It would still be 3 because that's the middle number. The mode wouldn't change. It would still be 3 because that's the most frequent number. but the mean would most certainly change. Now we can talk about variability. Variability is the measure of the spread or dispersion of a set of data. When we think about variability, we can think about consistency and spread. So spread considered the dispersion of a set of data. Now, if the mean was where the hole is on the golf course, and all these golf balls were spread out around the mean, that would represent the spread or dispersion of the set of data around the mean. And so, for example, a professional golfer would have a small spread. It would be very consistent, and the data wouldn't be dispersed. My golf skills, on the other hand, would be highly dispersed. So which set of data would have greater variability? So again, suppose the pin is the mean. Which golfer would have the greater variability? In that case, my golf skills would be the ones that would have the greater variability. I'm more spread out around the mean. Graphically, curves might look like this. So if we have some what's called a Pletty-Kurtic distribution, then that means variability is spread out around the mean. Versus a leptokurtic distribution, most scores are very close to the mean. So in this case, my golf scores would be more spread out. I would have a Pletty-Kurtic distribution. Now there are three main measures of variability. We have range, we have variance, we have standard deviation. Now if you ever looked at a research article, you might see something like this. In this case, this just means hypertrophy group, this means strength training group. That's slightly irrelevant, but we see age, and then we see this plus or minus 3.1. So that is what's called the standard deviation. And this will start to make more sense as we actually start to cover standard deviation, but you'll see that measure very frequently in research papers. Range is something that you might be familiar with. It's the difference between the highest and lowest scores in the data set. It's the quickest estimate of variability of data. It's only an estimate, and it's also very unstable. It can change radically if extreme scores are introduced to the data set. So let's take one set of data. We have the numbers 12, 12, 13, 14, 14, 14, 16, 18, 19, 20. 20 is the highest number, 12 is the lowest number. We get the range by subtracting 20 from 12. In this case, the highest minus the lowest is 8. If we added the number 55 into this data set, we would have to do 55 minus 12. And so now the range has increased substantially with the addition of just one number. So again, range is very sensitive to extreme changes in scores. Now, range only covers 2 points of data. Variance, on the other hand, is different. Before we talk about variance, we need to understand what deviation is. And that's how we determine the distance of data points from the mean. When you do this, the sum of deviations around the mean will always equal 0. So I'll show you what that looks like. Let's say that we had numbers 27, 26, 25, 24, and 23. In this case, we can say that our mean, the average, is 25. So to calculate the deviance, we need to know the distance of the raw scores from the mean. We already know the mean, 25, and here are all of our raw scores. So what we do, 27 minus 25 is 2. 26 minus 25 is 1. 25 minus 25 is 0. 24 minus 25 is negative 1. 23 minus 25 is negative 2. All of these scores will always add up to 0. So we want to find the variance. We need the average of the squared deviations from the mean. So in order to find the variance, we need to calculate deviance, which we've already done. And then we need to get the average of the squared deviations. So at this point, now we're just showing how we got deviance, 27 minus 25. basically subtracting all of our raw scores, or the mean from all of our raw scores. So now make sure that you're focusing on these numbers right here. So if we want to get variance, we need to square these numbers. So we do that by saying, what's 2 times 2? 4. What's 1 times 1? 1. 0 times 0 is 0. Negative 1 times negative 1 is 1. Negative 2 times negative 2 is 4. So we're just squaring all of our numbers right here. And now we have a sum score of 10. So we're just going 4 plus 1 plus 1 plus 4. Again, our number is 10. Now you've done almost all the steps to get variance. So we have our number 10 right up top. This symbol right here just means sum. That's all you need to worry about is sum. So we're doing the sum of our raw scores minus the mean squared, which you've already done right here. And then dividing it by n. N means the number of cases, which means 5. So in this case, we have 1, 2, 3, 4, 5 cases. So we have 10 divided by 5 equals 2, and that is our variance. Now, standard deviation is what we were mostly going to be interested in. So in order to get the standard deviation, we need to get the square root of the variance. I'm going to show you how this is done, but I also want you to realize that this can be done very, very easily by using the statistical software. But it's important to understand what standard deviation actually means. So standard deviations are the standardized, or it's called the standard deviation because it is standardized with the unit value of the original raw data. So right here on the right side we have variance. We've already determined that this number is 2. If you can understand variance, it's pretty easy to get standard deviation. So look at what some of the differences are now. Instead of n, which was 5, it's n minus 1. So this number would be 4. So now we have 10 divided by 4, and we're making sure we're doing the square root of that. So again, our variance was 2. If we're going to do standard deviation right here, it's going to be the square root of 10 divided by 5 minus 1, which is 4. So the square root of 10 divided by 4. So it's the square root of 2.5. And then in this case, our answer is 1.58. So let me show you this. If we had a set of data, as you can see, we just have 9 different numbers. We have 14, 16, 18, 18, 20, 21, 23, 24, and 26. Now, if we took this and just did summarize, and then we just did var1, which stands for variable 1, we would get a lot of the information that we would have gotten by calculating this by hand. We have range right here. We have the minimum is 14, the maximum is 26. So in this case, our range is 12. You can see that our mean is 20, and then it gives us our standard deviation right here, which is 3.9. And you will do the longhand version of getting this number, but realize that it's very easy to get if you're just using the statistical software. So we'll talk about standard deviation and then also the normal distribution. Pull this down a little bit. So when the sample is large and the distribution is close to normal, there's usually about 5 or 6 standard deviations within a range of a data set. So if the sample is large enough and the distribution is normal, again, so think we don't have any extreme scores pulling the mean in any direction, 68% of the cases will be within 1 standard deviation. 95% of cases will be in 2 standard deviations, and then almost all of the data will be within 3 standard deviations of the mean. So if we were looking back at this data right here, we would have 68% of the data would be in between the ages of 23.6 plus or minus 3.1. So in that case, we would say, what's that? 68% of the cases are within 20.5 years and 26.7 years old for this strength training group. So now that we've done this, we can work on a practice problem. Now, you have a set of data. You have 18, 21, 23, 24, 26, 18, 16, 14, 20. Now, this data is not organized. It's not in a specific order. So let's say that these values represent the BMI of 9 people. From this data, you're going to calculate the range, the deviance, the variance, and the standard deviation. When you do that, you'll round to 2 significant figures. Now, I wanted to show you this. This is part of the data that I already pulled up on Stata, where we showed that the standard deviation is 3.90. So this is the data organized. The mean of this data is 20, and the standard deviation is 3.90. So now within 1 standard deviation, we're going to have the numbers 16.1 to 23.90. So basically what we're saying is that 68% of the cases right here should fall within these numbers, should fall within 1 standard deviation. So if we go back to this chart and we go back to the numbers that we have, we would see 16.1 falls on the left-hand side, so on the negative side of standard deviations, but it's still within 1. 18 falls within there, as does the other 18 that's right there. Notice numbers that don't fall in there. 14 does not fall within 1 standard deviation. We have the number 20, which is the mean, so that's 0 standard deviations. It's right square in the middle. We have the number 21, and we have the number 23. So all of these numbers fit within 1 standard deviation. So we have 1, 2, 3, 4, 5, 6 of our numbers fit within 1 standard deviation. So in this case, it's basically 68%. So it's very, very close. If we had a larger data set, we would definitely see that 68% fit within 1 standard deviation. So this is the beginning of the practice for the homework, or for the homework that you'll be doing on your own. So after you've watched this video, make sure that you pull up the actual PowerPoint lecture and go through all of this to help yourself walk through how to figure out range, deviance, and then also the standard deviation.